All right, now we're going to try to solve radical equations. We're going to solve radical equations kind of similar how we solved absolute value equations, because we first need to isolate the radical or get it by itself. At that point, then we can raise each side of the equation to the same power. So make sure you're doing each side, you're doing the whole thing, not just each term. And then we can check for extraneous solutions. So if I have this one, the radical itself is already isolated. It's by itself. Now if I need to undo a square root, the opposite of a square root is a square. So I'm going to raise each side to the second power. That would give me a 4 because 2 squared is 4. And the square and the square root are inverses of each other, so they would cancel each other out and leave me with just a 4x. Then we solve for x by dividing by 4. So x is equal to 1. If we check, we can plug that into our calculator, but this would just say 2 equals the square root of 4 times 1. Well, 4 times 1 is just 4, so square root of 4, yeah, that does check out. So that is our solution. Now in number 2, we have a value outside of this radical. So we want to get that radical part, the square root, by itself. We do that by undoing this 5. It's being multiplied, so we undo that with division. And now I have the square root of 16x all by itself. And it's equal to 8/5. That's okay. We can leave things as a fraction or an improper fraction. But we want to get rid of our radical. We undo a radical by squaring both sides. If I square the square root, that cancels out, so leave me with just 16x. But then we square a fraction. So 8 squared is 64, and 5 squared is 25. So I get 64 over 25. We can divide by 16. We can also multiply by 1/16. That makes this a little bit easier. So x is equal to whatever this is, but I would just plug that into my calculator to make it easier. So if I had 64/25 and I multiply by 1/16, we still get 0.16, but we want to turn that into a fraction, so that's 4 over 25. Now, I multiply by 1/16 because I could have done this by hand, but if you just divided both sides by 16, you get the same answer. So 64 over 25, and we're dividing by 16. Make sure I'm putting that 64/25 in parentheses, but I still got that 0.16, which was 4/25. And we can check our solution. And we would check it by just plugging it back in. So in my calculator, let me just go back to what the original was. It was 5 square root of 16x. Now x we found to be 4 over 25. So let's put that in there. 4 over 25. If that equals 8, then it works, and it does. So now that is the correct answer. All right, number 3, I would square both sides because this square root is already by itself. Leaves me with x plus 6, and then 3 squared is 9. We can subtract 6 from both sides, but that would leave me with 3. So that's all we got to do, but we do need to check. If I check it out, square root of 3 plus 6 equals 3. Well, that's the square root of 9. Square root of 9 is 3, so yes, that does work. All right, number 4. We would square both sides because the radical is already by itself. Now, when I square both sides, I'm squaring the whole left and the whole right side. That would be x minus 3 squared. Now x minus 3 squared is x minus 3 times x minus 3. and it's equal to 3x plus 1 because it's canceling out the square root. If you already know how to square this, then you're fine. But if you have trouble with that or you tend to make mistakes, just go ahead and write it out twice and then do your distributing. We should end up with that x squared minus 6x plus 9 equals 3x plus 1. All right. The main thing that you want to make sure that you're not doing, okay, if you have a minus b squared, something like that, it is not ever going to be a squared minus b squared. It doesn't multiply out that way. We will never distribute a square. We will just write it twice, and then we can distribute multiplication. So that would say a times a is a squared, ab, and then another ab, and then negative times a negative makes that plus, so plus b squared. That's how we got this square, double, square kind of pattern. All right, now we can simplify this, and hopefully you realize we're working with a quadratic equation because we have an x squared. So if we want to solve a quadratic, we have to get it equal to 0. So I'm going to subtract 3x from both sides, and go ahead and subtract 1 from both sides, because that will make the right side equal to 0. So that would be x squared minus 9x plus 8. And to solve a quadratic, we either factor or use the quadratic formula. So I'm going to try to factor this first. That will make things a little bit easier. X squared we got from multiplying x times x. And then factors of 8. That could be 4 times 2, but 4 times 2 is not going to give me a 9. It could also be 8 and 1. That will work if they are both negative. That will give me a negative 9. So now we factored it. We would set each factor equal to 0. Use that zero product property. X minus 1 equals 0 and solve. So x equals 8 and x equals 1. We have two solutions. Now it could be the case that both of those solutions work, but it is likely that one of those is extraneous. So now we want to check our solutions. Let's check it, because if we do have an extraneous one, we want to see which one it is. So x equals 8 is one possibility. So that would be 8 minus 3 equals the square root of 3 times 8 plus 1. 8 minus 3 is 5. Square root of 24 plus 1 is 25. And 5 is the square root of 25, so that is correct. But we have to check our other solution. So let's try when x is 1. That would be 1 minus 3 is equal to the square root of 3 times 1 plus 1. Now 1 minus 3 is negative 2. And this is going to say the square root of 4. 3 times 1 is 3. 3 plus 1 is 4. But the square root of 4 is not negative 2. The square root of 4 is positive 2 because we're taking the positive square root. So this is not equal to each other. So we have an extraneous solution. So I'm just going to mark out that x equals 1 and x equals 8 is my only solution. All right. If you want to pause, go ahead and try number 5 and 6, and then we'll pick it back up and you can check your solutions. All right, if you did number 5 already, you would have isolated your radical. So I would get that 2 to the other side. So to undo minus 2, I'd add 2 to get 17. Then I can square both sides. The square cancels out our square roots. That's 2x plus 3. And then 17 squared is 289. I subtract 3 from both sides, so 2x equals 286. and then we divide by 2. So 286 divided by 2 is 143. But I still need to check my solution. So I'm going to go back to the original and plug it in. The square root of 2 times 143 plus 3. So all that's underneath the radical. So I'm going to go outside the radical now, press the right arrow, minus 2, and we get 15. So that does work out because I was supposed to get 15. So this is a correct solution. 6, if you saw, we have 2 radicals, and to undo a radical, we can square it. So I'm going to square both sides, and it ends up being just what's underneath the radicals, because this square cancels out with that square root, so it's 2x plus 5 equals that square and that square root cancel out, so 12 minus 3x. I'm going to get the x's on the same side, so let's move that 3x to the other one. It gives me 5x plus 5 equals 12. I can subtract 5 from both sides. That would be 5x left. 12 minus 5 is 7. And then divide by 5, so 7/5. But again, let's double check our solution. And do square root of 2 times x. X in this case is 7/5 plus 5. And it comes out to be this decimal. But we want to check to see, is that the same as this when I plug it in? So the square root of 12 minus 3 times 7/5. Those are the exact same decimal, so it is equivalent. That thing does work out correctly when I plug it back in. All right, we see some different things when we get to 7. We see those rational exponents, and what we were looking at with the rational exponents was that we could turn that back into a radical. But one thing we can also do is raise a equation back to a fraction. So if I talked about 2x plus 1 as to the 1/2, that would be a square root. The opposite of a square root is a square. So I'm just going to rewrite this exact same thing here because I want a little bit of room. Let's say I take this and raise it, that whole thing, to the 2/1. By raising it to the 2/1, I'm going to do it to the right side as well. What happens when you have an exponent to another exponent, or a power to a power? We multiply those exponents, and if I multiply this, they'll say 1/2 times 2/1 is just 1. They're reciprocals of each other, so 1/2 times 2/1 is 1. Because they are reciprocals, they cancel each other out, and I'm left with just 2x plus 1 equals 25, because 5 squared is 25. Now, subtract 1, get 24, divide by 2, and we get 12. We can still check our work. 2 times 12 plus 1, that whole thing I put in parentheses because that whole thing is to the 1/2 power. So you have the little exponent button that is to whatever power we want it to be. I want to make it a fraction, so 1/2. It still gives me a 5. All right, so we know that worked. For number 8, we can subtract 2 from both sides. X plus 1. If I subtract 2, that gives me a -3. And to undo a cube root, we would do the cube of both sides. So raise everything to the 3rd power. That cube root and that cube would cancel out to give me just x plus 1. But -3 cubed, if you want to do that in your calculator, is a -27. Then I can subtract 1, get -28. Again, double check our work. So This time I'm doing the cube root. And so if I did this square root button, it won't work. There is a cube root button if you do the other square root. So I'm going to click on that one, and that will let me change that value to a 3. So I'm going to take the cube root of negative 28 plus 1, and then go outside of the cube or cube root and add 2. We get negative 1, so that does work out. Last two here. Again, the opposite of a 1/2 would be to a 2/1. So I'm going to raise that to the 2/1 power. All right, so that 6 is also going to be raised to the 2/1. And I have 3x minus 4 equals 36 because 6 squared is 36. We add 4, that would be 40. And then divide by 3 is 40/3. That doesn't reduce. And then we just check our work. So I plug it back in. Parentheses, 3x, well x is 40/3 minus 4, and close those parentheses because that whole thing is being raised to the 1/2 power. So I'm going to raise it to the 1/2, and we get 6. So that does work. Last one, 3x plus 4. This is raised to a 2/3, and if we're trying to get rid of 2/3, we want to do the reciprocal. So I'm going to raise this to the opposite of 2/3, which is 3/2. What is nice about that is that's going to become 6/6, which is just 1. So if I raise both sides to the 3/2, it will get rid of what would have been a radical. So now 3x plus 4 equals, and let's see, what is 16 to the 3/2? I get 64. If I subtract 4, that gives me 60. And then divide by 3, 60 divided by 3 is 20. We double check this one more time and then we'll be done. So parentheses 3x, x is 20, plus 4, close that out. It's raised to the 2/3 power. It does give me 16, so I know that's correct. All right, there are plenty of these in the lab manual for you to practice and work on.